Hello and welcome. So today I want to talk about data reporting, specifically in SCIEX OS. This will be related to PFAS, but could be used in any type of method. So the first thing I'm going to do is open up analytics here, and I'm going to open up a results table that I've already processed before. So this results table will be for some 6500 plus data running method 537. When we look at this data, this is kind of how it opens up anytime you first open up something. The first thing we're going to do is go to a single compound such as PFBS. Let's start out with PFBS here. And we'll look at PFBS, try to see if, what the curves look like, what the peaks look like. Here's a blank and another blank. So we'll go to a peak here. This is the low standard. So we'll take a look at these. This is where you might do some peak review. One thing that you'll notice really quickly is if you look down at the table, you'll see some red and some blue. So what the red and the blue mean, if it's red, it means it's flagging high. If it's blue, it means it's flagging as too low. So these flags are set up in the results table method, and they're very, very useful. The way this data table is set up is that all the flags that you would have in method 537.1, things like levels in the blanks, asymmetry factor, all of this is worked into the method and worked into those calculations. And if you look at this sample that failed, this is the PFOA technical mixture. This is one that we didn't actually add internal standard to in the first place. So the fact that it's failing, the fact that it's showing that blue and red, and the reason it's showing is for IS recovery, that's fine because we didn't add IS to that sample. So you can take that out, you can exclude, so maybe it just ignores this sample from now on. But I kind of like leaving things like this because it's a bit of a positive control to show that the flagging is working. By seeing that, I know that the flags are turned on. I know that they're doing what they should do because it just caught a problem with an internal standard. So I'm going to open up the actual flagging rules in the results table method here. And so you can see, if you're familiar with method 537.1, these are the flagging results these are the flagging rules from 537, all input automatically into our table. So opening up one now, surrogate recovery. So you can see there's values here for just our surrogate compounds to flag them for their percent recovery. So it's flagging at 70 to 130%. And it's flagging these in all types of samples, just not the blanks or double blanks. And you can see the other ones here. Here's a field reagent blank. Here's where I've input the upper limit, which would be the cutoff. So this might be 1/3 of your MRL. I typed in 0.1 here. This could be higher. If your MRL was 3, this would be 1, etc. You could also get really creative with custom columns and have it to where if your MRL is entered somewhere or calculated somewhere, it would calculate this automatically, or you can just open it up and type it in if the MRL changes. And for some of these flagging rules, we have accompanying custom columns. Things like the asymmetry factor, we might actually need to do a custom calculation to make sure that we're calculating it exactly like 537 says. So here's an example of a custom calculation for asymmetry factor. It's the right half of the peak divided by the left half of the peak. And it's really easy to build these. What we're doing is we're using already any column that's already in the software or any custom column you've already made and just applying math to it to come up with a new value. Flagging rules were pass and fail. Custom calculation columns are to calculate a value. And so the value we're looking for here, asymmetry factor, I'm going to put in end time at 10% minus the retention time, and it'll be divided by, let's see, the retention time minus the start time. So that'll be the front half of the peak. And that gives us our asymmetry factor. We just have to put in some parentheses, order of operations, right? So parentheses here and parentheses at the front too. And that's it. So this will be a functioning calculation now. It'll show up. And if we set an accompanying flagging rule, it will flag anytime that asymmetry factor is out. And it's smart enough to give you options to only flag those first two eluting compounds, which is nice. You don't have to flag all the other ones. And you can only flag it in the midpoint standard. Those are all options here. So here you would review your curves. I'm just kind of showing what the software looks like, what the peaks look like. An interesting thing here, if we go into an internal standard, and I'm going to purposely manually integrate it, you see there's a manual integration flag, and this has totally messed up our PFOS curve. So in some cases, when you open up a curve and you think it's bad, it's hard to tell why the curve's bad. Here, it's actually pretty easy because we get that flag over on the right side, that little blue flag. So that shows that our internal standard is low. So a missed internal standard, a missed integration internal standard, maybe somebody forgot to spike an internal standard, might mess up your whole curve, but now you immediately know why. You don't need to investigate it. It pops up and alerts you to the fact. But in this case, it was just me manually integrating it. So once I undo that manual integration, boom, we're back to a good curve. Still the only flag on that data set is that PFOA technical mixture, which again, we expect to be flagged. We have custom calculations that will take into account your sample volume, your sample mass, dilution factors, and that's what that final concentration is. We're calculating the concentration in the sample bottle. So I'm going to show you here the sample mass and the bottle mass, trisma mass. Yeah, all if you need to type in all these masses when you submit the samples, they'll all show up here and you can use them all for custom calculations to get that final concentration. And then again, anything in the batch that you typed in, anything calculated here can be pulled into further reports downstream. So I used a report template here. I just clicked create report with the previous template. You can have as many different templates as you want. This is a QA/QC template. So this is going to report out your CCCs, it's going to report out your matrix spikes, that sort of thing, and show all the flagging that you would need for your quality control samples. So it's working on the report, it runs those Excel queries, it's chewing through the data, and I'm just zooming in here. This is what the reports look like. You can see sample names, you can see injection volumes, any information you want to put that's contained in that data file can be shown in the report. And now we've got a 1 page per sample and then 1 compound per line report. So I hope you enjoyed discussing the flagging and custom calculations in SCIEX OS Analytics. I can go into a lot more detail here. This was just meant to be an overview, a kind of like, here's what you can do little presentation. So yep, hope you enjoyed. Maybe next time I'll go into some more detail and actually show you really how to create these and kind of the do's and don'ts and tips and tricks of it. So thank you for your time, and I hope you enjoyed.